In this video, I'll be sharing how you're going to work on greedy best first searching algorithm and how it works and how it searches. It is a type of informed searching technique. By informed search technique, it means that we have some prior knowledge. By prior knowledge, I mean that we have some information that we can use. This information is in the form of heuristic cost, or it is in the form of actual cost. Actual cost means that the distance between nodes, and heuristic cost is mean that the estimated cost from our goal, from our initial node till our goal node. Also, it uses evaluation function. Evaluation function means that what will be the next node that will be selected. It's based on some evaluation function. In this scenario, the evaluation function works on basis of least heuristic cost, meaning that from this node, we are going to select the next node based on least heuristic cost. And we are going to select that node, and from that node, it will become our current node. And from that node, we are going to select the next node based on the least heuristic cost. That's how greedy best first searching algorithm works. So like our breadth first search and depth first search, it also has an initial node and it has a goal node. To find the goal node, you should see heuristic of 0. Wherever the heuristic of 0 is mentioned, it means that this is the goal node. In this scenario, our initial node is A. It means that we are beginning from A and we are going to search. So some important points that you should know are greedy best first search algorithm uses depth first and breadth first searching techniques for its traversing. For its searching mechanism, it used these two searching techniques. And what's different then? The difference is heuristic cost or evaluation function. So how we are going to evaluate which node we are going to select next from A. As I told earlier, the least cost node will be selected, least heuristic function that has, it will be selected. And it uses greedy approach. This is called greedy approach. Why? Because from A, I'm selecting the node that has least heuristic cost. So this is a greedy approach. And it expands using our heuristic function. So that's all. Now we are going to do an example. So our initial node is A. The next node that can be selected is 4, B and D, because it has heuristic of 4 and C has heuristic of 5, so it won't be selected. So in greedy best first searching algorithm, we have a concept of open and close and make it easier. So how we are going to use it is very simple and easy. Initial node that is in our open list is A, and it has a heuristic of 7. So it will move from here to our close node, and it will be A is our initial node, and it don't have any parent node. After this, we have these options available, B, C, and D, and heuristic cost is 4, 5, and 4. From this, B and D can be selected. So how we're going to select B and D? Both these options are now in our current or in our open list, and their next option is going to be the taken, and from that we can calculate our heuristic cost, and the one that has least heuristic cost will be selected. So from B till D, we have a heuristic cost of 4 plus 1, that is 5, and initial 7 is also added. A, D, and G, we have a heuristic cost of 7, 4, and 3, which is greater as compared to our 7, 4, and 1, which is 5. So this will be selected, and B and E are in our open list, that it has heuristic cost of this, and then from open list, they are going to be added in our closed list, that is B and E. B has parent A, and E has parent B. After that, we have H. Why F is not considered? Because F has heuristic cost of 3 and H has heuristic cost of 0, so it's selected, and the next element that will be added in our closed list is H, and it has parent E. So these are the elements in our closed list, A, B, E, and H. This is the optimal solution for this graph. By optimal solution, it means that this is the least heuristic cost path that will be selected. 7, 4, 1 is less as compared to 12. It gives, on this path, we have heuristic of 12. If you check the other path, it has heuristic of 7 plus 4 plus 3 plus 0. It makes 14. And it's greater as compared to, so it's not selected. There are other points in greedy best first search that are important. It doesn't guarantee a shortest path. There might be some other shortest path, because shortest path is based on the distance between the nodes. So as it's not considering the distance between nodes, it's considered an astatic. So it doesn't guarantee you a shortest path. The good points in greedy best first search algorithm is that it's easy to implement, it's fast, it's a low memory requirement, it's flexible, it's efficient, but it keeps track of every node in its memory. Also, time complexity of our breadth first search is OB to power m. Let's check this, where B is the number of branches and m represents depth. Let's calculate complexity of this OB to power m. where B is the number of branches. Count the branches 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is 11. And the depth. How are we going to calculate depth? Depth is like this. This is first step, this is second, this is third, and this is fourth. This is the number of levels that are in this tree. So we have 4 levels here. So 11 to power 4 is the complexity for this graph. This complexity can be increased if we have more levels, and if we have more nodes, complexity will be increased. So this is how you're going to solve your greedy best first search algorithm. It's simple, it's easy. Just consider heuristic function and heuristic cost. The least heuristic cost node is selected, and this process is. Let's take another example. In this situation, we have this graph. R is our initial node, or sorry, P is our initial node, and goal node is S. As you can see, S has a heuristic cost of 0, so you should know that this is our goal node. So we have a list of open list and closed list. This is our open list, and then we have a closed list. In our open list, from current node, all the options are listed here, A, C, and R, along with their heuristic cost 11, 6, and 9. From this, obviously, C will be selected as it has the least heuristic cost. Continuing from this point, we have in closed list P and C. The parent of P is none, and the parent of C is P. Continuing from this, we have further 3 options, M, R, U, which have heuristic cost of 9, 8, and 4. Obviously, 4 will be selected from here. And then from U, we have in our open list N and S. N has heuristic cost of 6, and S has a heuristic cost of 0. Obviously, 0 will be selected as our goal node. And in our closed list, we have PCU. And after this, we have S also added in our closed list. So from this, we can calculate our total heuristic cost. That is 10 plus 6 plus 4. That makes 20. So 20 is the heuristic least cost that is required from our initial node till our goal node. Repeat it till we reach our goal. That's it.